Well, thank you. I accepted an invitation and realized there are a lot of things I'd like to have dialogue with the computer-human interface people about. And through the years, my path sort of diverged off, and I didn't have very much dialogue consistently with what you'd call a professional fraternities. So I thought I'd make up for it, and I'd come and give you an informal sort of thing, because it's pretty easy for me to try to get into gear and tell you, hey, we ought to all be bootstrapping the world and so on. So there are a lot of things embedded in the stuff that we did for all the years that I just would sort of like to show and tell. And some of it is probably going to die with the species, and some of it is, I think, worth considering integrating into the future. And so what I'm going to do is a mix of online stuff with this creaky old system augment and some slides and a little bit overhead. And you know, I got targets to get to, but I don't care much if we get there in the evening. So I'll just get started. How do we turn on the projector? Oh. Is that readable? We'd better get it readable, because there's going to be quite a bit of that through the evening. So what do we do about that? Who's... No. I think I could do without light here. I can work in the dark. So is that yet readable? Yeah. All right. Yeah, they're just trying to be nice to you and not make you all in the dark. I probably don't need any light if it comes to that. Of course, it'd be fun. One of the things I'm going to show you guys is how to use this. And it's part of our world for many years. And it did a debut with a mouse back there in 1968. And somehow the world passed this thing by. And I always felt a little bit slighted about that. So a little later I'll show you more about it. So anyway, I've used it so long, and you can do everything from the keyboard that you can from that, and this is just a supplement. But I've done that so long that when I have to divert my attention to a keyboard, I stumble badly, so it's practically impossible for me to give a demonstration without that. So a little later we'll tell you what that is. But this is what it reminds me of, is starting out in that 1968 presentation where I was up there at audience right, telling people, looking back and forth what they're going to do. But it's a different audience. I don't have to say what files are and what mice are, I guess. But anyway, I'm going to start out with a brief history and then explain to you a little bit how we're supporting this system, and then my objectives for the evening. See? So I'll explain the commands later that I'm using. So what I want to do is talk to you about the objective of my big pursuit, and I'll just give you a bit of that world and some of the slides. But the basic thing I'm after is improved organizational capability for handling complexity and urgency, the product of complexity and urgency. And slowly through the years, it's getting people to sort of take that a little bit seriously. And this has led then to saying, well, that implies to me I developed this model for what it is that augments humans, gives them more capability than they were born with. So that augmentation system model, and I looked at that, and that looked very, very complex and difficult to cope with. So it's just saying, all right, what you need if you're going to go after an organization's augmentation system is definitely a strategy, because it's a very, very big, complex thing to pursue. So I was saying, well, if I'm going after improved capability for handling complexity, and that's a complex problem, why don't I try early to help leverage that by finding out which new capabilities that help handle complexity could also be applied to helping improve the augmentation of an organization. So that resolved down to high-performance integrative knowledge development. How do you like that? And I've given it many names over the years, but I'm just saying, look, if distributed people can learn to work together to integrate their different knowledge domains and efforts to develop knowledge in an integrated way more effectively. And then that's the target. So I filtered through a lot of things and said that seems to me to be the highest payoff target. And somehow in the mid-70s it didn't register very well with everyone who was interested in office automation. And then in the early 80s, when everybody was interested in personal computers and spreadsheets, it didn't really register very well either. But nowadays it's beginning, and organizations are interested in total quality and enterprise integration and the like. So slowly, maybe I'll come into fashion someday. Anyway, so the upshot of trying to pursue all that for me ends up with this sort of a bootstrapping plan. And I said, well, if I could get a bunch of organizations to participate by mutually contributing to a prototypical pursuit of improving this kind of capability, and then as they do and learn that thing, they can start acting like a real consortium, but a very brand new kind of consortium in being able to integrate knowledge and support back up the line. And the very first thing, of course, they would do is to really learn how better to do this high-performance integrated knowledge work and use it for their work, and their work would be to improve it pretty soon. A little bit recursive. So anyway, that's just the rough picture of what we're trying to start now, is actually start a consortium initiative to do that. And it's a little bit hard to explain to busy executives that have to fork over the money, so, but we're going to try. So anyway, that's sort of where I stand. And the history of that is I started out at SRI and built the Augmentation Research Center many, many years ago, and we started the Network Information Center, and then we were forced to leave all that behind and get pushed out in the world and went to Timeshare, bought this system called NLS that we had and renamed it Augment. It was in the commercial business for some time, staying alive by supporting people who thought they were doing office automation with us. But we had some big organizational activities that were very educational. McDonnell Douglas bought Timeshare and TimeNet to integrate into an integrated, an information systems group. It was about $1 billion a year business, and way off in the corner of that was this little Augment stuff. And I got the chance, though, to go through, roam out to the aerospace side, which was much more in tune with what we were offering, and lots of sort of encouragement by some champions and tremendous discouragement by the system. So a tremendous lesson between Timeshare and McDonnell Douglas in the real problems in changing organizations, and the real problem is getting people's perception moving about what can come. So you've probably heard the term paradigm a lot, but that really is the issue. And tonight, one of the things I'd really like to sort of get through a little bit is, if you're talking about computer-human interface, and that's a challenge, you ought to look about paradigm-human interface, as people somehow absorb unconsciously a lot of attitudinal things that set for them a paradigm with which the way they look at things. And you come up with something that's really quite different, and depending on different ways, and takes a different way to think about it, and it's just extremely hard for us humans to shift. I don't say those humans, because after a decade or two of getting sort of rejected, it finally dawned on me I was like that too, and the ways I look at things, and I just happened to start out looking at it like this. So anyway, the ability to learning how to get our organizations and our people to start shifting their perceptions about what the world can and should become is just a totally critical thing in trying to make it happen. And the cost of the equipment is practically negligible compared to the cost of the organizational shift in culture, skills, and learning. Some of the things I'm going to tell you about computer-human interfaces tonight will stem from a shift, and I just know that as broad-minded as some of you are, I mean, there's going to be negative reactions to it, and that's okay. I won't take it personally. But I think more and more through the years I become more and more confident that this shift is really going to take place. And so anyway, that's a very brief history. What I'm using today is I'm going out through a modem over to the Stanford network and into a DEC 20 at Stanford running this augment system. So what you're seeing on here is 2400 baud handling this system, and much of that interface and all has been the same since 1970. And so there are a lot we would change if we'd had the money along the way and add some of the nice graphic things, but there are a lot of things about this that we wouldn't want to change. And you don't sort of feel it until you live it. So if I, for instance, use a one-button Macintosh and the most modern of the editors, I just feel crippled for how to fly. So we'll show you some of that. So my objective this evening is to try to relate to you some of the aspects of both the changes in paradigm that some XX-human professionals need to start thinking about, and other ways shift into also some of the computer to human things that I think are going to be relevant to this. So someplace now we can turn this off, turn the slide projector on, and switch into something else, right? Great. How do you like that? Come on, George. Okay. So I've been going through this for decades with people, but this, a few stages here, what I arrived at in the conceptual framework that was what really sustained me since 1960. And it really starts out saying, well, you've got a problem. You want to augment the knowledge worker, and I finally ended up with this basic picture that there's a model of a human in this simplified sense. And you say, well, it's made up, of course, of a pretty big mental capacity, and some of that's conscious, and a lot more than we generally appreciate is unconscious. And we've got nice sensory apparatus together with its processing that you call perceptual processing going on, in a lot of ways to affect the external world and our motor things. And somehow that package, as it's born, has a capability to learn a lot and cope with the outside world. But as it's born with these basic human capabilities, it's singularly incapable of coping with the rest of the world as it is today. So what do you add to the rest of that? Well, there are things in each of these zones that you add. You realize that the child starts learning a lot of this unconsciously and a lot of unconscious and conscious concepts and begins to talk, and gradually learns more and more about things that he can actuate and tools and things in the outside world. And these three zones of things your culture gives to you. So there's systems of language, custom, tools, and methods so that the human's tiny grasp could cope with the large tasks and problems. If you really start to thinking about at any one step or something, you really can't do very much. And if you're a powerful mathematician or programmer, it's little tiny steps you work at through the days that finally add up to something big. So it's marvelous the way all those little steps knit together to give you some action that can build buildings and big computer programs. And it's marvelous the kind of conceptualization that you can do in there, but all of that was developed culturally. And what does it amount to? So it's you know, I just gave that a name. I said, you know, call that, that's what augments our basic human capabilities. And that's all there is that can augment your capability. You can add spiritualism in there if you wish, and you can add, if you add extrasensory perception, those are a little bit beyond what I could start engineering-wise cope with. But otherwise, that's all there is. So you said, gee, that's easy. We'll just fix up that system and make people a lot more capable. And you start asking yourself, what is it that makes us think that the particular augmentation system we grew up with, you know, matches the human capabilities here to produce what percentage of net potential effectiveness? You know, we just somehow think, well, the world has gotten here. History was forgetting to hear. See, well, where's history going to, you know, we're part of next century's history, and, you know, where will it go? So I just felt like there's a lot of gain there to be done. So there are things in all of these categories here that you could call human, culturally derived sort of aspects to that augmentation system. It's a very important part of it. And one of the things about the paradigm shift is, how much do you think that among all of this, how many of the things in that human system are candidates to be changed if you just want to clean up the world and make things a little more effective or something? Well, we grew up just accepting all that, and that's part of that paradigm of people just not sort of considering that those things are candidate for change. Well, I was lucky enough in the 60s and trying to figure out about all this thing to just challenge and say, boy, what would you change in there? Well, for one thing, you realize that there's another side to all the artifacts and tools, and well, that's going to be just revolutionary. That's just going to change like crazy. Well, what's it going to do? Is it going to do anything on the other side? So you realize it's really a two-part system, and all through the centuries, those have co-evolved. And then when the technology can come here, I think I'm running out of ammunition here. All this technology making something so radically powerful here, and somehow the automation-oriented people just thought you'd use this to automate these things. And growing up, emerging in the early 60s with this picture of augmentation, it's a whole system, just naturally start asking, well, what can you do on the left-hand side too? And so that's what I wanted to start doing to help augment, is to make some effective new starts in the left-hand side along with new starts in the right to make a difference. And this is where it sort of led me away from what everyone else is doing and set me apart enough. So another natural phenomenon known as, what do you do with the radical political guy? If someone is speaking just a little bit too far out your cone of acceptance politically, right, left, forward, backward, whatever it is like that, it becomes just hard to deal with him. The guy is, gee, he doesn't bend, he's off there waving his arms about this. Let's just sort of, ignore him. He may be a nice guy. So some of my friends used to tell me that, Jesus, you're a nice guy, but you still act just like a charlatan. So anyway, like that. And so anyway, that co-evolution of those two sides is about the only way you can deal with this complex thing. So that's the paradigm thing that I sort of would like to start communicating to you about. It's sort of like that. And if you look at just an example of where that can go, you says, well, take any compound capability a human has or an organization has, and it's a composite built up of all these things, of a lot of skills and knowledge and attitudes, etc., down in here. A lot of capability you extract from here and put it together with this to have a capability. So those composite capabilities are what you want to improve, and scaling-wise, there's going to be immense impact on the left side. Anyway, so I won't feel so badly if my stuff collapses halfway through too. So. Anyway, so so then one of the kinds of things of thinking about that is, suppose you build a system that's going to really help all this happen, and you look at any reasonably complex organization and you realize of all those functional domains that are going on that are operating concurrently, and you realize that, well, whatever I do about really augmenting the individuals, and I want to boost the capability of the whole organization, I have to realize that all those links there are interoperability channels that have to function. And if I'm going to move from a world of paper to a world of working online, and along the way I'll probably give up a lot more paper, and WYSIWYG is not going to mean so much to me, thanks anyway, and hyperdocuments and linkings are going to mean things. So the guy in the marketing guy sends a message to the legal guy to ask him something and points to something over there a customer had, and the legal guy needs to go click on that link and end up being able to read what that customer said in his document, and if that references some specifications are not meeting that are someplace else, you have to just be able to follow all of that around without all kinds of terrible transformations and moving into new conventions about how does somebody deal with a link or a reference or a citation or something like that. So it's a horrendous challenge compared to anything else we've met. And so this leads, for instance, in that airspace there, that the government's making big companies team up now and divide a very tough airplane project. Very, very, very complex airplane. 2,000 or 3,000 people in each organization, each one of them representing all that interoperability, and they have to interoperate. And then they do their business with these tiers of suppliers, many of whom they have to exchange a lot of data or give you the specs and you build it for me and test and send back. A lot of exchange, and a lot of it is legal and responsible, and a lot of variation up and down that whole system. So you look at that complex and you talk about an interoperability need. So it's really easy to show how you can bomb around inside of knowledge bases, but can you get a knowledge bases that can be shifting and evolving at the response of all the concurrent work those guys are doing, and they can all move around inside the spaces like that together too flexibly? Well, if you can deliver something like that, it would save hundreds of millions of dollars a year and do just tremendous value in almost any industrial segment you want like that. So why don't we do it? How do we get there? Well, it's a tremendous challenge to learn our way and shift the paradigms of all sorts of people in order to make that come about. And one of the paradigms might well be yours. So listen closely. So down inside that integrative knowledge development stuff is a sort of thing like this. You know, something I call a handbook, because somehow there was no generic name for what is the product, the knowledge product of a collective work, of a project. So, you know, I said, well, call it a handbook. And it's going to be an online handbook. And when it's going to be online, everyone's going to be working on that, and all these things are going to be concurrently developing and changing. And there's going to be a lot of dialogue about it among everybody. And the whole group is going to be collecting a miscellaneous set of information from the external environment and integrating it too. And all of this is sort of their hyper-document knowledge domain, and integrated in that with a lot of numerical and analytic sort of tools that are interrelated too. But I'm talking about sort of the knowledge development here. So that cycle going on all the time within any one knowledge domain is extremely critical one, and it's exciting. So it's that kind of work that we set about really trying to make effective inside of the Augmentation Research Center. Okay, and one way of talking about it is if you've got the different domains, it could be individuals or it could be any other functional domains, but that's the sort of interoperable shared space. So you just have to have interesting shared files. You have to have some way, you know, this you don't have to, this is the model that we built. You've got sort of throwaway mail, but the throwaway mail wants to have links in it that can point into this stuff. And then you've got the library in which you can put any one of the documents and it stays and it gets anchored forever, and links to it then it can count on, and those can be documents that you can sign, etc. So that represents the real record of what went on at different times. And as these get superseded, okay, but there's still at any one time that handbook is really represented by a set of stuff here and indexing to that. And you do want a way to handle offline documents and keep records and tracks of those. And the same kind of cataloging can do that, work with that. So there's a lot you can talk about and all that, but that's sort of the model, you know, of pursuit. And so when I'm showing you online stuff a little bit now, it's sort of derived from that kind of a thing. And so I published a paper in the Computer Supported Cooperative Work Conference about knowledge domain interoperability and an open hyper-document system, an OHS. So this is how I'm characterizing that probably something's going to have to evolve that produces an open hyper-document system by which we can do all of this intensive integrated knowledge work And many domains can also be interoperative, so your domain and my domain might be merged for quite a while working in common on a project. You might be doing the software, and I'd be doing the requirements, and somebody else ends up with the operating specs, or the user operating specs, and all that fits into a project. So all of these things interoperate. So the picture is you'd have your source code in these things, and all kinds of stuff. Anyway. So now we'll make a few steps about how in this kind of conceptualization we model the kind of system that we ended up building. So it says, all right, with this model here, what is there in the human's head that you can start working with? Well, I didn't want to go too deep or abstract, so as an engineer I says, oh, concepts. Yeah, everybody can deal with that. And the concepts end up being linked in some kind of structure in your mind. And so that wasn't so bad to say. So you got that inside your head, and then when you develop language, you develop symbols for those concepts and could do quite a bit of symbol manipulation in your head, and you even develop concepts and symbols for the relationships between other concepts and symbols to get grammar and the like. And so all that, and even cultures that don't have written language have a sense of grammar and all of that often. So then the big challenge, if you're trying to externalize that, is our model has always been you write on paper, and that's what you were out to do when you were automating your office. And I sort of say, well, gee, is that what you're really trying to do? So this is sort of the picture here. You get computer tools and languages for controlling them, and your methodologies for working, and that lets you, in your model here of your WYSIWYG papers, you can write and manipulate that and view it, WYSIWYG, and print it out and hand that to the outside world, and that's augmenting, see? And this just didn't meet the kind of picture at all back there. And it was sort of unfortunate, because that's what everybody else in the mid-70s said that was what the computers were for, and that we were way off the ball. But I just somehow, that's not taking advantage of the shifts in the left-hand side in the human system that are possibly there. Because what are you really trying to do? Trying to externalize? Gee, that's not a very good map of what's in my head, that paper. So could we make a better map in the computer file? Oh, that's sure. You could have any kind of list structure representing any kind of model of a conceptual structure you wanted to have. Oh, that's great. But if you did put that out there, it would look like such a mess of pointers and tags in there that you'd have a hell of a time reading it. And then you could say, oh yeah, but the computer as an instrument could help me read that too. It could give me the views that help me comprehend what I wanted to comprehend, just like my mind generally does of those concepts that are in there. So why don't I think of the computer both to help me develop that map as well as to study it and look at it differently? So that I says, all right, why not structure it? What kind of structure? Well, I could start with a hierarchy, but that's awful simple. Really, maybe it's some kind of compound reentrant network. Oh, well, I'll start with a hierarchy, because that's easy to handle, and after a couple of years we'll learn enough, we'll go into more compound stuff. Well, we never quite got to those other parts in our system, but just having the inbuilt hierarchical structure plus links has been very, very powerful, and it's one of the things you'd like to be able to support in some one of the, in some mode of almost any hyperdocument thing you want. So anyway, it says, well, let's make an external map of the human's internal concept structure so we can help ourselves write that, and the explicit file structure that models our thought and knowledge structures, and the computer-aided structuring, so it's an opportunity. So let's take that opportunity. And here's the model of what the system was. Here's the model of what the system was. Is going to fill out all those blanks, but that's the 1960s model that we built, if you can hang with us. So it says, all right, manipulate content and structure and integrated text and graphics into the computer storage and make it be a model. And the human sitting off their light with his motor actions could control all those slots to do the things that computer tools let him do, and with perception to watching what happens on the display. And so also new is you got the chance in there, if you're having discrete structure of your conceptual objects, of giving them addresses and names in some kind of concept space. So why not? You know, you're used to doing that. Let it be part of your mental map, and it yields more computer help. New, harnessing the names and addresses for distant jumping or manipulating. It's an opportunity to use the human's ability to know names and structure locations. You do it all the time when you're telling somebody how to get someplace or where to find a book in your office, so why not start doing that in your new kind of document? Well, that's a paradigm shift. That isn't a document. Documents are lines and paragraphs and pages. He says, well, come on. A document is really the external map of what you've got in your head. So now we have a much better chance for doing it. No, that's a paradigm shift, and I'm not shifting paradigms today. I'm doing human interfaces or something, see? See? No, but anyway, it's just something that sneaks up on all of us, that there's another way to look at it that's the more general and actually what we're doing. So a automobile is not just a horseless carriage. See, it's another kind of a way of talking about it. So the computer-aided helping thinking is not just another book. See, and WYSIWYG is very interesting, and we'll see that that has a place, but that isn't the only way you want to look. So I actually made documents structured like this. And so in the left hand, you can see my laser pointing to the things in the left hand, that where there's actually a ring structure of neat little modules that very easy if you want to restructure the different data. It just changes the pointers in there, and the numbers 1, 1A, 1B, 1B1, etc. that are there implying the location, those are not an intrinsic part or property of any one of the nodes. It's just a location address in a hierarchy. That's the way we designate it, like that. So anyway, and then, but the human has a concept of a document, and the structuring, we'll just give some examples of that later. And you also, since you can address things and all, you can actually have textual addresses that can move you around and show and point to things, that you can employ those textual addresses that are embedded in the text and convention like that. So using that instead of subterranean sort of addresses and pointers a computer knows about but aren't meaningful to the human, turns out to have some advantages in this simple world, which we'll try to point out later. And so there's another aspect to all of this, and one of them is, how does your mind move around inside of that set of concepts structured in your mind? Well, I'll tell you how it's supposed to do it. It's supposed to load, file, scroll to the point. Right? Right? Sure. Whereas the computer's got the capability just to go right to something. So he says, that's what I'd like it to do. And I'd like to begin to get the capability to affect that by telling it where to go or pointing to a link to go there. And when I get there, I need to get a feeling for where it's at. And other things. Think of the abstraction levels. I tell you, hey, I want to talk to you about your car. And you get a picture of it sitting there all rusty or shiny or whatever it is. And then he says, no, I meant the driver's compartment. Oh, there's a picture of that in your mind. I meant the instrument panel. There's that picture in your mind. I meant the fuel gauge. So you're capable in your mind of just moving instantly to these different levels of what you'd call detail or abstraction in there. So why not provide that support system? Well, it turns out that structuring the documents lets you do that. So it's one of the... So it says, well, look, we got an option. We could ignore the line and page breaks that don't carry meaning. We have an option to show addresses, labels, referencing attributes, etc. if we wish. We got an option to filter by level or content if we wish. It's an opportunity to abandon the paper-dictated geometry so that we can now view content and structure in flexible new ways. So I thought, boy, that's what we're just doing, is starting to take advantage of what you do in the left hand and modify the right and do the coevolution and shift your paradigm. So that's important to get things like that started. And unfortunately, it didn't sell very well. but it stayed alive, and it was really interesting that we'd run up time after time of getting this system where it was just about to get a big chance. They'd have some real champions in the organization that get all excited because it could do just very unusual things to support, and they'd write a proposal for the next year to boost how much they were going to spend to support it and use it, and wider range of things, and this would now have to be up a different budget level to get approved, and this guy wasn't involved in any of it, so he only gets a 20-minute presentation about it, and what the hell's all this? So he'll turn to his MIS guy or something and say, do you know what this stuff is? And beats me, I never heard of this stuff before. But I'll tell you what, Fred, if it were any good, IBM or DEC or maybe even Xerox or Apple would have been doing it, so don't fool around. So it just, 5 times it got up some really good chance and then just crashed like that. But anyway, it's enough experience and all that to know that this kind of system, even as antique as it was, is in the sense of the horsepower of the machinery being used, it was just a very, very powerful application. So we don't, when we tell people that the structure and the viewing and the jumping and the explicit naming and addressing are really powerful, we're not kidding, because it's been out there being used where there isn't anything yet out there in the modern sort of framework that can do the same thing. So that's where this is something to change. So anyway, alternative to making nicer printouts is composing, studying, modifying, and communicating online. A different paradigm from automated paper generation. So there's paradigm shift. So we say, all right, what's this business of a human paradigm interface? We talk about that. Shifting that paradigm is important. The interface between a human and the augmentation system that supports it is a really general thing. So how does the methodology that you're supposed to employ fit with you as a human? How does the sort of social structure in the work group you have fit with you as a human? See? How do the skills you use? How do the physical skills? Well, you get down to some point where the human factors people or the interface people are talking about here, but there's a very, very general thing, and the concurrent, you have to do the coevolution and concurrent design. So you can't be refining the design in one aspect of your computer interface, you know, while the paradigm, your paradigm is going off like this and the rest of the world's got to turn like this. See? So what are some of those sort of shifts that may come about? Well, we got to the point of looking at, this is sort of our 1968 version of NLS was sort of like this. You know, storage in there, since you had explicit addressing and stuff, file position is very important, so you had all kinds of ways to remotely jump. And since you had addresses on all your objects, you could manipulate them without looking at them too, which was handy. So when you got to given file position, then you evoked, there was a view generator there. That's what ended up producing something on the display that you could visualize. And we also added the feature from way back for years that you'd like other people to be able to see your screen if you wanted to, which again is a paradigm that it's just inevitable. So then there were a few more things to think about in all that. And this next one is fast concurrent control. So that's, it says you got all this horsepower with you, you have 400 horsepower, and you got this machine that'll go zooming along very fast, and do you have all this counterbalance, special cambered wheels, turning and control, and front wheel drive so you can really take turns well, and analog braking? No, you get in there and get out, because your horseless carriage, the way to control it. You don't. You don't, do you? No. And I'm not implying that anybody's system is like that, but you know, because mine's like it's got racing controls on a 1920 car here, see? See, anyway. So anyway, you say, if I'm going to have lots of horsepower in here, and I'm going to have a lot of flexibility to move around and view and manipulate in there like that, you know, I want to be able to control that thing appropriately. So he says, yeah, but you know, you're a beginner, you got to be nice to it. I says, no, I'm not arguing about that. I just would like it so that, yes, it's easy to learn, and the beginner can get learning, but I don't want the person's going to fly in there for many, many, many more hours to be trapped in a mode of interface that's nice and easy for the beginner. So the marketplace does strange things to vendors. You know, they really aren't free to shift a lot of stuff. You get a base out there, you get an image of what you are, how your interface is, what it is. The whole marketplace out there generates a momentum about the interface of what the interface generates the picture of what all that should be, and who's going to be brave enough to shift and change it? See, it's gambling a lot like that. And if the user organizations out there keep chugging along and buy whatever it is that comes up that's the best, and the trade literature is working out in there like that, they stay and digest things. Where is it that's going to break paradigms and shift? Well, someplace in there, there's got to be some sense of new responsibility out there, saying where we want to go. And let's not argue with things that are very successful in marketplaces, and especially when the user world was relatively immature as far as what to do. But let's keep looking for ways to move categories of users who want to move faster and be more and more powerful. They want a bigger vocabulary and more eloquence in it, and more flexibility in employing it. So they ought not to have to keep using the same one. You ought to be able to plug in your kind of user face. So I've got no prejudicial things at all in all of this, and it's not because I like to see the world try this. Don't have to use it, but I really like them to say, well, here's an instance. People look at it and say it's very hard to learn. There's another aspect to this, besides fast concurrent scroll that we wanted to have, and that's this bottom one. It says, we want an open, we want the provisions when you're working in the interface to have an open-ended vocabulary. Because who can the outset say how many classes of objects you want to employ in here, how many nouns, how many different functions you're going to want to call forth, the verbs you're going to have in there, the adjectives and the adverbs that go with it, etc., like that. Well, in the 70s we were building these systems so that could be open-ended, and people would just laugh at us. They'd say, hell, in my editor and mailer, I don't need more than 30 commands. Why are you going to all that trouble? And we'd say, but that's going to be a different world. Well, I think everyone realizes now it's going to be a different world. And so whatever interface you want, it should be able to adapt to open-ended. So this is where strict reliance on menus and icons really is going to have a lot of trouble. And so one thing underneath that is to say, look, but at least everything I'm going to employ there, I ought to have nouns and verbs, etc. in there that we all talk about. And whether I use it for a menu or an icon or a term in a command line or something like that, it should all have that nouns and verbs in clear mind. And then we can move ahead fairly well. And then how it is that persons evoke when they're communicating that language. They'll be able to speak pretty soon, etc. So some combination of all that to get an extendable vocabulary that's very powerful. Because otherwise, we'll all be trying to do our science with pidgin English. And so, geez, this is terrific. I can just barely see you, and I don't very often. When I sit around my house, I never get to talk like this to people without feedback. I'm just going to go wild here. So there's another aspect of this. If what's coming about is that your whole organizations have to start zinging together in all of this, you need some picture of the kinds of trends in the architecture. Well, it's pretty clear, since we were very, very lucky to be the second host on the ARPA network and start up the ARPANET and realize that this kind of environment was inevitable. So we started, our architectures actually started shifting towards this in the late 60s. So we're just saying, all right, I have workstations or terminals or whatever out there. We called them workstations from the beginning. And I'm going to have this sort of whole network of networks. And I'm going to have information and servers scattered around there. And people would tell me in the late 70s, oh, but it's all going to be in here, it has to be here. And the PC people were saying it has to be here, and we're saying, trying to tell them, no, look, even though you can have as much power in here as we used to have on our mainframe, you're still going to want to be connected. Well, that was a paradigm shift that the PC world just went zooming off and totally ignored. The fact that it was valuable to tie them together, and that the ARPANET and the Ethernet kind of things that were out in the 70s would be very important. And even IBM coming out with the PC just didn't provide for it. So that was really one of these cases where the market went zooming off like this. And boy, now it sounds silly that no one prepared for it. And it wasn't a matter that the technology wasn't ready. It was that the people weren't. The technology was. This place here was a pioneer in getting things networked and stuff like that. So anyway, that's a real example. So what are the examples that we may be not looking at today? Well, this thing moves on a little bit to say, so one of the things is, too, that people don't want to get too tied up with that your workstation is going to have all your horsepower and data, because these networks are getting faster and faster and cheaper, and that shift is going to be something that, anyway, I forget which button I'm pushing now. So this is just saying another thing about the kind of paradigm shifts that it seemed to us. So we built, Augment's built like this, and all the service in the back end, and a procedure call interface, and remote procedure call connection with that, which, as far as I know, we had the very first remote procedure call working in our systems very early. And I'll just leave it on. So then your server back here looks out here and can connect anywhere through the network, or even if they can run that way inside the same workstation host like we do if you want to. But anyway, you've got that interface that gives you the chance of locating them any place. And then this end looks out here and sees a virtual terminal. So it knows it's always working the same kind of virtual terminal. Depending on how your terminal is, the module looking at the terminal characteristics does whatever transforming it needs to serve this terminal and display and everything in a way that as closely as possible can fit the virtual one like that. And then every event that goes on there gets handed to this interpreter, command language interpreter. It addresses the grammar file for that particular application grammar, and also for the user profile's particular characteristics to decide what to do in feedback and when to send off call to get some service, like that. And so it just is a matter of flipping and switching these grammar files to change your whole interface language, or changing this to change the style, and changing subsystem code that went along with different grammars. So if you had some kind of generic hyper-document structure out there in the world, you get packages like this that you could buy from vendors that would be standard interfaces into that would do all the work you wanted to. Well, real smart applications and utility people could have all kinds of things that operate on that to do work for you, and you could have the common language throughout your whole organization with any style interface that fits you, as long as it was compatible with that conceptualization and your profile for how you like to view it and see it. And then you make up your command scripts that can be operated like that too, so you can compound, and this has sort of a natural structure for sort of a programming structure, but you use the same nouns and verbs in your work here and designations, and otherwise you've got lots of flexibility. So that's the model that we thought the world was going to want, and so that's the way our system's built. So what I'm going to be showing you is that. It turns out that I think this is just an intelligence test and I'm flunking. Oh well. So anyway, the things I always wanted to say is that uniform language throughout an organization. If you ever stop to think about it, as an organization is going to shift in its dependence and increase much more the dependence it has on the sort of looking into its organizational knowledge base in a very much more flexible sort of way it's going to be. That the terminology's got to shift and grow as the organization's mode of working and thinking grows, and it's got to be uniform. You just cannot have different dialects around that use totally different terminology for the functions or the objects that are in there. So this is just, you just can't imagine. The organizations that have those islands just can't be as effective. The personnel can't be as flexible about where they work or what terminals they sit down on or where they shift into what departments or functions. The ability to bring in new methods and tools that are used across functions would just be terribly bad. So anyway, that's a really important thing, and this is one way it looks to us that can make that happen, is to have that. So having your nouns and verbs and adjectives and adverbs or something be everybody in common, but you still have the style chances to change them if you wish and evolve. Then it becomes a question of your own, you're using a style that is slower and less effective because you got anchored to it. Well, then that's just like you sort of don't learn as much about what goes on in your organization as another person, and you suffer for it. But you have the flexibility going. And plugging, well, anyway, enough of all that. I came to the end of something, so I should bang this, I guess, right? So that says, all right, we're going to shift back to, turn that one on. See if that works. Yeah. Can people still see it? Read it? All right. So anyway, I will just do an augmenty sort of thing. And so we've gone all through this kind of picture here about basics. That's an augmentation, an interface between humans and their augmentation systems, the enterprise integration issues about that, and the human paradigm interface that's really pretty important. And so I'm getting careless. So here are a bunch of things then about the concepts and features. Now we'll be turning and talking about augment and how things work in that. And so what I'm going to do is I'm going to talk about that key set. See? And so let's turn this off, and I'll turn this on, and I'm going to give you a very high-powered lecture. If somebody didn't lose my... Oh, it's there all the time. Yes. It's not true that the older you get, the less you remember. I think. All right? Boy, you can have a lot of fun with little kids, in various ages. I started playing games with my 3 daughters, and only one of them is here helping me still tonight. She can remember when she was 5 and a half. One Saturday morning we started playing games, and there's an algorithm about how you can wire up the electronics to have successive pulsers come along and make flip-flops toggle. So you can turn that to a little old man who walks along like that, and a picket fence, and if you've got to lift a picket, he's so tired he has to go home. And then the next time he can change every picket he comes to, but when he lifts up one, he has to go home. And that algorithm will start getting your pickets changing with a very funny pattern. And pretty soon the kids are beginning to anticipate that pattern like that. So at that I say, well, look, and I take their fingers and I put these numbers on their fingers. And I say, great. And so the very first walk the guy takes, the number 1 comes up. The next walk, the number 2. The next walk, oh, it's 12. No, add them, it's 3. The next walk, it's 4. The next is 5. The next is 6. So you say, oh, So the next day, I took the kids and I said, the next weekend, we did this. The first day I said, just imagine you could be in class and if somebody asks your sister a question about an arithmetic and you could tell her the answer and cheat in class and no one will know. That got them really turned on. This is what they call moral indoctrination or something. So anyway, it's like the next Saturday I says, just think how you can cheat when you can talk. And within a week they were talking. So and we later on at SRI we actually did some formal experiments where I wanted to set up a way to do computer-aided psychomotor skill training with people. So I just thought, well, here's a skill no one knows already. So we hired temporary Kelly girls, and they sat down. Some of them, they'd ask, here's a character you're supposed to hit, and then it'd be a pattern see on the screen. Or other ones we would shoot jets at their fingers to stimulate them. And we had 3 different test groups like that, and 1 control group that they just were given the list and to learn it. And all nicely psychological testing and all of that. And what failed about all of that is that they all learned it so fast that you couldn't distinguish, statistically between those groups. It was a matter of about 2 hours. So whenever anybody tells me that's too hard to learn, and I look at those little girls cheating and those Kelly girls flying through this thing like that, you just have to realize about paradigms that looks hard and different. Well, so does driving a car or skiing or riding a bicycle, see. So anyway, let's just show you. You could take your left hand and on your knee you could start. 1, 2, 3, 4. Are you doing that? Come on, you guys. See? Because you can do this while you're driving. You can talk to yourself. You can talk to yourself, see? And it's really kind of interesting. And then someday somebody will notice you sitting in a meeting and going, see? And it's funny, so you really can learn very rapidly, and you learn this is a D, and this is an H, and this is your pinky is a P, and this is a T, and what's one more? Q. PQR's TU, what's one more? Oh, it's one more, that's easy. Well, what's V? Well, it's one more than that. So if you learn a few in the middle, you can always count up or down, and it's really very easy. So you can just practice, see? And so one day I told my wife, about this in meetings, I was telling her how much fun it was like that, and she laughed too. It was optional, keyboard or that, and so was a mouse or other things optional. Pretty soon more and more people were sitting like that, so almost everybody that's ever gone through using our environment flies it like that, and it's just very, very easy and flexible. And let's just show you a little bit. And you could adapt almost anybody's interface that way. So what I'm going to do is do another, oops. All right. I'm going to shift gears. And here's another window that augments looking at another file at. And one of the characteristics we said is, Windows, and if the world's going to be like that with its different document structures and like that and all these utilities, you don't want every window to be anchored to one application. A window's looking at a particular place in a file, and I can bring forth any application I want to apply to it. So that's the way we do. So the command line sort of up there is separate from that. And yes, we do use command lines, and if I hit a D, and we get recognition. And so full. So all I had to do is hit the D and I get the feedback. And if I want to delete a word, we go to that trouble. And I hit a W and I get the feedback. And no, I didn't mean that. Oh, I can backspace. It says one event backup, see? And I can hit, I can say I delete text. Or as a matter of fact, if I said, how many things can I delete? Oh, if I can find a question mark on a keyboard, I can ask it, see? And it says, of course, now this is over 2,400 baud, so your menu doesn't fill out very fast. And so that might be one reason why people tend to learn how to fly these pretty fast and not depend on menus. But what we really chose to do is not have Control X be cut and everything like that, is try to link it mnemonically in with a particular style of input we have like this. So there is a mnemonic algorithm, etc., for going ahead and picking those. So then the whole idea of having nouns started to be apparent way back early, where if you're going to go click on an object to say what you want to have say to do with it, if you tell the computer what class of object it is, it saves you a lot of trouble and gives you a chance to do a lot more power. See? So he says, is that right? Well, then over the months and years that this has been going, this is a basic set of sort of objects that delete will work on. And they look strange to you, and that probably will turn people off, and they'll say, well, that's not the normal vocabulary. But look at the value of it. I'll say, well, I'd like to delete a word. Well, let's insert something. Any place. See, I'm going to insert a word after that. And we also have this weird effect that when I start typing, the echo is up here. Well, one of the reasons was when we first started working with this over networks, you had very, very little processing back home here. A little 4-bit microchip was what started like that. So we had to conserve a lot on that. But later, began to realize, because I can say I want to insert a word any place else in the whole document structure I can reach by giving its address, where else are you going to see it but up here as you're typing it out? So it pros and cons, and a lot of times, like right here, I really would like it brought in there, and he says, all right, that will be done. So let me show you the key set. See? It just works pretty rapidly. See? And if I hold the middle button down on the mouse when I'm doing that, the computer knows I'm in the text entry mode. Right? So what if I hold another button down? I see that, or another. So I have all those options that you can start learning if you wish, and it's very, very nice. So there are only a couple keys on this standard board that weren't there in ASCII when we made this, so we have to hit it like that. So it really becomes very valuable. So I said, well, I'd like to delete the word arbitrary up there. See? See, there's the word I'm looking at. Oh, let's do something else. That makes the cursor a little more visible, right? Yeah. God, makes you seasick. Okay, there's the word arbitrary up there. And my attention was here, but my eye went up there and saw the word arbitrary, and I wanted to delete it. So, on the way up, my left hand says DW, and my right hand did it, see? So I said, well, wait a minute. I think I would like to say subordinate instead. Oh, I'm going to copy this word to go after that. So I only had to say copy word and click on that any place, because I used one extra character to designate the class of object. The computer knew how to parse and pull that up and could shift it up there like that. So I could have said, well, let's move the word subordinate to come to, oops, come after sample, see? So there again, it just does it like that. Oh, let's transpose this subordinate with this word statement here. That interchanges them. Well, moving and copying like that, where you do directly, or transposing, how long would it take in cutting and pasting to do the transpose? A little hard. So anyway, it's very handy. Then you start saying, what if I say, let's just protect that someplace else. So what if I say, I want to say delete the word statement there? What do I want to have happen to the quote marks? Come on, you guys are designing this interface. Oh well, here's what happens to it. He says, that isn't what I want to happen. Well, what if I want to replace that word with this other word, subordinate here? I would like to have it left in the quotes, wouldn't I? So I want the definition of word not to include the quotes. Well, then what will I do that includes the quotes? Oh, well, we get another term we call visible. That's any successive sequence of visible characters. Oh, let's delete that visible. No, let's replace this visible with that visible. Let's copy this visible to follow that visible. Let's delete that visible. See? So if there's a visible, well, what do you do about something like that? It says, hey, I only wanted one space in there. All right, let's replace that invisible. Any sequence of invisibles with one space. So it takes me just exactly sort of one stroke of my character the key or a keyboard here to designate the class of object before I go pick it so the computer knows what I want to pick. Well, you remember, we'll shift gears a little bit. I've got some news for you. We're not going to finish at 9 o'clock. We ought to have some kind of agreement that should I stop at some clock time and let people have to go? Or are you grown up enough to leave when you have to and I won't take it personally, or what? All right. We'll come up for air at 9:30 and you can leave before that if you have to. All right. Another kind of thing of objects that each of these text entities here, strings of text things that look like lines or paragraphs to you, are explicit objects in the file too. So I can also say, all right, delete a statement, bing. Well, I'm going to copy a statement. Let's copy this statement here to follow that statement. Bingo. It takes one click at each place because it knows the class of what I'm trying to do. Let's move this statement to follow that statement. Oh, and since we got structure, I'd like to have it go below it. So one click says go below it. I hit a D. See? So move that statement to follow this statement. And up here, it offers me the option of striking a letter, L level. So I just hit one D, and it'll do it. See? Boom. So, all right, what if I do something like down here, there's something called a branch. See, it's this statement and these substatements below it is a branch. What if I say move branch? Move that branch to follow that branch. Well, what's this branch? This is this one plus these two subs. So this new one is going to follow that. Boom. And I have a sneaky way to remembering what I saw before. That's what we saw before. And as a result, so it just moves a branch. And so we have having these nouns is very, very handy. And it's pretty hard when you say, well, look, I'll double click on something and that'll take the word. If I triple click, it'll take the paragraph. How do I get? So if you have explicit structure and explicit sort of branch, things start to really happen. Let's do something else. We talked about addressing. See? Well, one thing I can do, we also talked about viewing. So there's a command that says set view spec. And we started out way back by making commands that were long with words and stuff that tried to describe how you wanted to change, turn off the numbers, turn on the numbers, add this, add that. And they were so bulky and slow that it was just very hard to use them. And finally, we just came about as saying, well, we need something fast and cryptic. So that's what we did that we brag about. It's fast and cryptic. No. People had to go look up cryptic. Anyway, I'll just show you one is, so if I hit M And there is one way I can, when I say execute a command, one option of hitting 2 of the keys instead of 1 of them on the mouse to execute says, oh, and I want to repeat that command. So if I do that by repeat, it comes through, and if you can see it, it says, okay, these are the location addresses in the file. And so any given time I can operate by watching those if I wish. So some people just gaily plug along with those things on all the time, but it kind of gets in the way visually. And if you want to, you can say, well, I'd like to see them on the other side, and they'll be over here, and that's sort of handy too. But most of the time we don't really bother. No, wait a minute, I can't say that. You get used to where you are, sort of, and you don't care if you're at 17th and Main. You just sort of are interested in the house numbers up and down Main, or the fact that where you are, so you don't kind of bother watching the street signs. You look at the structure. So when you want to turn them off, you can do that. And so you can flip them back over like that. You have another option in here of saying, well, let me look at this thing without any space between it. So it'll do that. And sometimes you like to see more. Well, you've got a line down here, and some of these statements are they're all very short. So you say, well, what if I wanted to make them longer? Well, I'm going to just say, for the hell of it, I'm going to copy this statement to follow this statement down a level, and when I get down there, I'm going to append it to that in a funny way. So appending, you say, well, I got a whole object, I can just say append. So now I got a statement with 2 lines. Well, another one of my options is, say, look at something with only 1 line. And then you start to get in the realm that the outline processor. So that's very handy. And it starts affecting people's writing styles. They start putting things in the first line of the paragraph that sort of tell them what's in the paragraph. And is that pretty sneaky? And we've, in our laboratory, we used to have, really good people would come to work there. And after we built up a lot of momentum and quite a vocabulary in here and style of working, I began to notice this thing of people start getting very restless and unhappy after a few months. And they'd come into my office and talk to me and sort of like, well, people used to like me. Well, what do you mean? Well, they're sort of avoiding me. Well, what do you mean? Well, I knew after a while, about the 3rd or 4th one, that they were starting to try to tell people that what you ought to change in here. They were looking at this much of the system they'd gotten learned with, get experience with, and wanted to start changing. And people really, you don't want to change this because of the larger scheme or paradigm you're in, but if somebody has got a PhD and a lot of experience and knows what's in there and won't believe you, they'll think you're trying to just put something over. So people learn not to polarize it by not getting in big arguments, so they sort of avoid confronting the issue or the question they had, so people think they don't like them. But it would take 9 to 11, 12 months for people to really soak in a lot of this environment. And it was a really interesting experience about that. So it's the kind of thing that we know there are a lot of reactions very early, but there are a lot of people that live with that now that have been off on what any modern system they want they can have, and they still say they'd rather work in this kind of environment. See, so the one thing we're trying to do is find a way in which some pilot operations can go where people can live like this and merge this with the other things that are coming, which are a lot of great things to do. But until you've got a system that sort of supports all this wide-ranging things like this, how are you going to know? Well, anyway. Incidentally, we started 2 years ago almost giving 3-day seminars about all this paradigm and what you can do with it and the strategies and examples. And we're going to give another one, so we brought some flyers here tonight that... Oh, out in front. Yes?
Can I look at it 1A and 1B only.
1A and 1B?
Branch 1A. Branch.
Can I look at 1A by itself?
And 1B.
Or 1B by itself?
Can you collapse it at a given level?
Look at only one level.
Look at n levels.
Like that? What, is that what you meant?
Yeah. Right.
This is just getting on with the view. And you notice if I want to, I jump, I say, well, a minute. We've got a lot of other terms too, jumping. Jump to the head. Jump to the head of this one, where's it going to go? To A. Then I say, well, I only want to look what's under A. Oh, well, any more under A? No. Well, what's under the rest of them if I want to look at the line like that, see? Oh, I see. So there are quite a few variations of how you want to look at that become part of your vocabulary. And then some of the outline processors that can do even more flexible things than this, you'd like to add some of that too. But these have worked beautifully for many years. Let's start talking about jumping. And with the numbers on, you know what, I'm going to do something else. Is that okay? Look what happened here. I'm saying one line only there now, so I only see that much of one line that'll show in that little window. If I said, oh, show me all the statements, they fold themselves up in that window to show you how you wish, see. So if I say one line only, no line in between, then I got a nice flexible way. I can say jump to that one, and that address is now fixed in the computer, and I can move the cursor over here and say what kind of view I want, and I see the view there, see. So this is kind of handy. I can say jump to that one and look over here. Oh, I see. Well, let's jump to that one and look at it here, see. So that's very nice, because a lot of times over here you'll put that kind of truncated outline, and like in programming work or something like that, it's just very, very flexible. But let's do something here. I'll say I want to see just that one by itself. Now jump item to 1B. See, I can't see 1B, but I can type in the address, and on the left you can see what 1B is like. And before every jump, it gives you the option to affect the view if you wish, see. So I'll say, oh, well, show me everything in just the branch under 1B. So it did that. Well, now there's another nice feature. It remembers where you were, so you say jump return, and it goes back. So when you're doing some debugging in source code, you jump to a procedure, you see it named in there, and you jump return, and you're back, just like the code's supposed to. But anyway, then I can do something in here if I want to. I can say, oh, here. I'm just typing in it, see? That, we did this very imaginative thing of saying we'll call that a link. And that's an address that's embedded in those little things, so the computer, if I say jump to link up here at the top and click on it, it'll take me there. See? This is a branch, like that. Jump return. And what's more, the syntax of that lets you say, well, if I put a colon there, then I can add view specs. So if I say jump to link, and incidentally, I can click any place up here, and the computer knows to go this direction to find something that meets the syntax of a link, and then follow it, see? So it goes there and changes the view. So going to some place and viewing it are what these reference things does, and that little simple thing just starts compounding what you can do with it. And so if I start with this one again, I can do something like saying, oh, I'm asking it to show me some of the hidden parameters. On that, every node's got its own independent parameters underneath some properties. One I'm asking it here is saying, what two characters, if they bracket the very first word, so to speak, will turn it into a label or name of that. So this one is set for a null and a colon. And it turns out you can set a whole branch or a whole file or any individual statement so that first word will be acting like a label. So let's just come over here and let's do something very imaginative. Say insert in front of that thing, I want, how about this for an imaginative label on that? See? So anyway, so let's just try that. Let's just say jump to an item named Kai, so I can actually just type it in there like that. Ooh, hey, that's great. So I can add those labels anytime I want to. And in fact, if I want to, I can say, let's just label it. I'm replacing that word with that word. That's pretty easy. So let's just see how that works, see? So I say jump to link, boom. So it's really starts, you can not only structure your file and organize, you can start labeling any kind of file you want and jump to it by that. So as you rearrange the file, then it doesn't, you don't lose your place, so to speak. Well, that's a very valuable thing, as everybody who's, written source code and had to move it around did. But then also there's another thing in here that you say, well, let's show another kind of identifier on the front of these statements. And these are all integers that happen to be written with a 0 in front of them. And we call them the system gives that identifier to each node when it's created. And it doesn't change when you move it. If I move that statement to follow this one down there, it's going to end up there, and it's still going to be 0555. It's just this internal serial number. Well, that number also is a valid address any given time you wanted to. So let's say I'm going to copy this link to come over here, just to have two links that stay there. And then let's replace that Kai as an address with, let's go down and pick, oh, well, while we're at it, why don't we just pick the one that's the same one as Kai is, see? See? So this should go the same place as Kai does. And if I want to prove it, I'll just say, sure, see? So if you're working with a file that's very changeable and you want to be pointing to it, you can do it this way. So you say, well, isn't it clumsy to have these links be just textual things? And he says, yeah, it'd be nice to have them be actual objects that can be buried and viewed in different ways and all, but what is really, really nice is the fact that the generalized address string that contains in them is human readable and human viewable, see? So these links can get much more extensive than that. You can you say what file you want, go to some given address. When you find that node, go to the first one underneath it and go to the third successor. And when you find that, take the first link you find in there and go to that, and then da-da-da. So you can just compound all those things as much as you wish. So how you would apply all of that thing in your methods and conventions for how you keep your documents and your reference and linkage and such has got just a lot of room for imagination. So somebody can say, well, I'll agree to have a file that's, here's the file identity, and it's going to be open to your whole group, and in there I'm going to have a branch named Kai, and underneath that I'm going to have, the first thing I'm going to have is the announcement for the next meeting, and the next one I'm going to have is somebody else's pointing off to where so-and-so keeps the best current references. Oh, so I know I can make a link that goes to your file, down to Kai, down to its sub, and takes its link, and that'll go over to wherever the announcement is now about the next Bay Kai meeting. And I can just leave that kind of address link always. Anytime I want to find the Bay Kai meeting, I click on that, and that'll go Richard Anderson's file down in there like that and off to the announcement. So you can do that with all sorts of interesting information. So the thing of having addresses that you don't have to see, that you can employ, that you can also use anytime you want, or I can say move statement. I don't have to mark it, I can address it. I can say move the statement name Kai to follow the statement name 0705. That's this one here, see? And I don't have to be looking at anything. And when you do, make it down below. See? So let me... you turn this off. I'm going to shift to something else for a minute. Yeah, all of the source code's been in this. As soon as I show you this other, why don't we just jump and I'll show you the source code. It's just the whole 100,000 lines of code is all reachable. Inner stuff between it. Now don't forget to do your homework, kids. So what I want to see is a lot of little kids walking around with these numbers on their fingers because it's intriguing. All right. Here's the way we publish a document now. See, so format it how you wish, and then up here. Now we told you about the library, the journal system. You can have lots of independent journals, and that would be the OAD journal. So this was item 2250 in it, and so forevermore, in your environment, you say you want OAD, 2250, and that looks and says, oh. What's a file designator is just a straight integer, so that means this is a journal, so it goes, looks up there and finds the catalog and go get that item for you, and we'll let you look here. And if after a comma you add one of these location numbers, which is printed in there, then bingo, you're right to that. So we say, if you're going to have addresses, and if you're still going to be interacting with people with paper sometimes, it's very handy to have a convention for printing it out so the addresses are visible, so that somebody looking at this can address it. Or if I see an email or something else that cites that link pointing to this item, I know this is the passage he was talking about. Or conversely, if I look at this document and I'm sending an email to a guy or calling him up on the phone, I can say, hey, look, OAD 2250 at 3A. And we can go get it. So what we'll do... Oh, there's some truth about getting old. Here's a page in that document back there, page 10, see? So back here is item 7C, window views. So this happens to be a document that describes a lot of the characteristics of Augment that I'm showing you, see? So why don't we get online, and remember, it's OAD 2250, 7C. And we would like to just, as a reference thing, just go jump to it. So there are just tens of thousands of documents. The original Augment journal is up at 132,000 something or other. The numbers are at it in now. So why don't we do this? We'll say, and let's add a new link to that. Right, and now it was 7C, right? And do we want to view like that? That means I want to look wide open in its natural form. So, okay, let's go do that. Well, if I go in this window, I'll crowd it up. So why don't I go over in this window? I didn't tell you about this window, did I? That's another sort of thing they did. Well, the virtual terminal, we tell the system it's this big, the display. And then this screen is a port looking into that. And if I want to, I can have some very quick ways to go back and forth in that thing. Or I can shift and push it with the cursor. So anyway, if you remember over there, I clicked, so it's going to actuate on that link. And then I go over here and do my final click, and this is where it's going to jump to. So, one jump. Yep. Hey. Come on. What did I do to myself? Here it is in this window. Did we set up the parameters like that? This isn't the configuration of windows I usually use. However, I'm going to pretend like that's all right. Let's just see if that will. You know what I think is we've just moved from another host to one inside of Stanford. And we found out that when you go through the tip, you have to do some funny initializing of the tip to tell it that to handle the escape character that will let us use this widescreen. And someplace tonight when we went in and all this excitement about having company, I forgot to do that. So I'm sorry. So anyway, that just shows you how the link worked. And then we've got a command that says jump return file that'll take me back at there. And if I say, really when I get there, the kind of view I want, it looks very weird like that. That says, I don't know what level that is, but whatever level it is, oh it is 2, well not worry. Add 1 to it. 1 line only says the T. Z says no blank lines between. G says I don't want to look at that branch. N says don't have any numbers on it. So it's cryptic. So this is what you'd probably shoot somebody off to look at. And it's very beautiful. He'd look in there and he says, oh, well that's interesting. Let me see where I am in this file. I'm going to jump up and look, viewing over there. Oh, that's controlling the views. And so this is the window views and that, and user specified and everything else like that. I see. Oh, that's pretty good. Well, what if I wanted to see the whole file and look at it from the top level? That's the way it is. So it's not an outline processor. It's just the viewing that you can do to look in. It's very flexible like that. So I'd say, oh, anyway, this is one way of using references that you can look in. There's scads of stuff out there. Let me show you another thing I can do. Is if I can say jump to link, and it prompts me for either marking a link or typing in the text of a link, or here it says the option is you can type in the address of a link. Oh, let me take that option, and M, comma, means go to a file named M. File name M is my mail file. If I just went to M, comma, it would go to the very node top of that file. Well, as it turned out, the first thing I put there is a link that goes to a branch that's, I said NM for new mail, and has a view that'll look at my mail in there like that. So that's all I have to do to get there. So I'm using an indirect file, and boy, that goes into my file named M, and goes to branch NM, and shows me these things. So it says, oh, here's mail I picked up at 3:19 today, and so on like that. And these are just the top of the branches, and each one of those is a message, a mail item that came in through, and these EXT ones came out from internet, and the other ones are from augment users, see? It tells what mail group, the identifier, and something independent. Well, as it turns out, you can also notice if I look at what's the name identifying on these things, it's all null null, so it means that every one of these identifiers is a unique label for that mail thing, and I can jump to it anytime I want to from a distance. So let's just, here's a message that I can say jump to that and then open it. And Twain Stone, I says, gee, Jim Norton has done a lot of work on making handbook. And that's really structuring and putting a lot of conventions for links to get a really online handbook. And he just did a beautiful job. So I said, well, where does he store that to send me? So I could go looking out through that. He says, oh, here it is. It's a Norton file, augment handbook, and here's the view to look for a starting point. Well, let's just go look at that, see? And so bingo, that's clear off in Norton's place, I don't know, thing like that. And here's the view where he made into an augment reference handbook. And there's just a lot of stuff in there, just tremendous. And he's got conventions, where someplace it talks about the overview and the conventions, but he just says, well, if you want to click on that, it's the fact that there are colons there means that that's an internal link that's hidden underneath there. And I can just go looking through that. So this would be a way in which you you set up a sort of a project, so I can jump to return anytime I want to back there, and follow all this down. It's anyway, you can just and ultimately it gets to a place where there are other kinds of links, like right here. See, dialogue in general. Well, let's look. So anyway, it says the catalogs and indexes to a lot of these different journals. And if you wanted, you could just go. So these are the catalog for the different years for what's in the journal. And so you could actually go look at the catalog if you wanted to, if that's where your handbook wanted to lead. Well, that's going to take you to a different file because you see that link in there. So it's just what I think I'll do very quickly is go look at some source code, and then we'll get away from this. One thing I can do with source code is I've got a file named F and a place in there named FDIR that I always know about, because that's where I keep my own file directory instead of asking the exec or a finder for it. And these are the equivalent of a whole bunch of folders or something, but they're just branches. And every one of those down inside there are links, descriptive links to files. And I'm looking for one about programming, so this is the one down there. I just jump to that and open up another level. And here are the different kinds of programming I do in there like that. So I want these executable ones. So here, more categories. Oh, the content analyzer ones. Let's go look at that. So now I actually see the link structure here. These are the files and the types and the version of the file and how many pages in it. And then my notes about it that I can write however I want to edit. Those are just editable notes. And there's a very interesting one there that's the process I call and evoke that updates this file whenever I want to. Well, where's the source code? Well, it's a sequence. Well, let's just look at the sequence thing. We didn't talk about the macros, but there's a command sequence that executes in the different levels of it, that executes and employs that program to update my own homemade file directory, see? So you can get at that very easily. And then here's the source code, see? It's in a file called pxutility, dirkit up like that. So this jumps to that source code file and looks at a view where here's the program and the global declarations and then all the procedures in it, and they're labeled like that and what they are. And so I can just look at any of them very easily, and I say, well, what about this parse one? That looks, well, here's the one that it gets called first. And you just go look at that. And so, of course, that's not going to be very big. And you says, all right, what do I do here? And it's going to call some other one. So here it called another one. This is a call dpass here. Oh, boy, sorry about that.
I'd like to give people a chance to ask your questions.
Oh.
Can you maybe provide some closing comments so that we can open?
Yeah. Okay. Yeah, this is roaming through the software, and there's some very interesting things this will do. Sure. Thanks, Richard. Are there some questions that we can handle for a few minutes or forever?
I think before we ask questions, I think we should give him a hand for the tour de force he's just done.
Thank you. That's
Now if you have to leave, you can leave.
yeah, that's right. You've been polite.
What would you have done differently to get more acceptance of the system in the early days? Because, you know, the satisfaction of having people adopt your ideas 20 years later is fine, I'm sure, but it would be nice to have it closer to the time that you originated.
Yeah, I don't know. It would have been nice, for instance, if we could have let other people use it, but by the time other people had time-sharing systems, ours was so big and took a lot of maintenance and support, and they would like it free, but we couldn't afford it unless they paid, and so there was that. And I don't know. I really sweat with that, because what we're trying to do now is the same flavor. And I'm just sure that this kind of bootstrapping would make a tremendous difference, and it's very slow. So that's all the answer I can give. So you.
Have you thought at all about how this system could be adapted under a graphical user interface, so you wouldn't have to remember all the commands and letters?
Oh yeah. You also at any given time can ask for the question mark menu, or you could turn it around and have the menu be all the time, on that way. Or we actually, the program that runs in here that makes it look like a virtual terminal, somebody reprogrammed it in C and got it almost working in a Macintosh. And so you can go ahead with rip-off menus and work on it. And when you get, it's still, you'd say, well, you don't like to use characters to drive it too. Should we use the same characters to drive the menus here as in this one? So yes, and then you could learn it soon. And if you're using the key set, you could go. I think that'd be a great way to go if you had your options in different places. You'd like to not be bothered with menus, or if you hesitated for a few seconds, the menu would show or something. But one place in which the menu kind of thing was really a problem is when you do a jump, how do you adjust the view specs? So it ended up with a dialog box that filled the whole screen. So there it would be like that, and you could look there and go click and click and click. But you also could see the letters next to it that you'd hit. So after a while, you just would hit those letters to do it. And what we're really in this consortium thing, the design for an open one would be that you'd have something like that in each different class of workstation. So we're trying to open that up to that the people that are using that to start exploring, and then compare how they work in different ones and find out. So,
Is the code available? Can we get a copy and play with it and play around?
well, it only runs on DEC 20s, and it's an unmaintained programming language that we had to build ourselves starting in the 60s because we weren't on machines with good compilers. It's just it's like the animals in Madagascar that got separated, and so we'd like to build a bridge now and see if we can intermarry. Well, let's see. There was somebody way in the back.
Yeah. Have you tried this with voice navigation?
No, it'd be interesting. I just have some crude analogies about it, and I think you'd have a hard time with voice navigation being as facile as this way, unless you. Oh,
Keep using the mouse.
oh, as a parallel, yes. I really would like to see that, and that's part of the extension. Is that I'm sure that'll come about. You know, like I'm sure you're going to walk around with all the horsepower you want here with gigabit wireless connections into the network. And what are you going to do when you've got it this way? And then you put on glasses and your virtual reality is in there. Is there other questions?
Yeah, just to pick up on that question, why do you think your keycard input device failed, and how do you think it compares with latter-day input devices, like the Data Glove?
I don't know. I just have to try it. The only thing you can do is see if in the whole spectrum of work you're going to have to do, how they fit and how you'd have to adapt the rest of the interfaces to them. And if the glove really could start coding in the air, that'd be great because you've got so much else flexibility. And I keep telling people that these are likely to be superseded, and the mouse will, but put the open mind about people learning to, it's like talking your skis down a hill is the analogy I get, that I don't think that would work very well. So that flying through this space, there's a lot to learn about going through it very rapidly and calling for the functions you want with all of the options and everything that are going to start appearing and the skills that you'll get in going and maneuvering. It's going to take a big vocabulary and a flexible way to communicate it.
On other quarter keyboards like the microwriter, they use letter shapes to help you remember the chords.
Yeah.
Do you find that any easier to learn than the binary system that
I found it impossible to learn. I tried it for 2 seconds and it no, I don't know. I don't. That'd take some study. It turns out with this sort of numeric way of counting your way up and down and finding the letters and remembering a few in between, it's so easy. And I don't think that the shape of the letters is, you know, I doubt if that makes the transition to first learning it any easier than this. And then I used to read about that there are different kind of chords that your hands more naturally can do because of some linkage between these two fingers. And so somebody predicted that you would only get, I don't know, the prediction rate was way slower than people can do. And when I watch experienced people go along like that, they go breezing through those chords without any hiccup at all. And I really wanted to make one with 10 different keys and each finger taking care of 2 of them that could hit this key or that key or in between. You hit them both, so you've got 1,000, what is it, 1,020, you know, you get chords and just see what you can do. Somebody did an analysis with like that and said, well, you could probably get down to 4, let's see what it was, I don't know, but quite a few words per, I mean, anyway, you could really go fast if you learned. And those things.
Could you give us a few comments about your consortium that you're forming?
Yeah. I used to call it the Bootstrap Community or Bootstrap Consortium. And I have a way of talking about the change process in organizations where there are some activities that go on that do the work, call that A. Other activities that are there to improve the capability for doing A, that's B. And there's some activities that improve the capability of B. And so I said, well, why don't you get a consortium to share the work of the C, to give the change makers new capabilities to do their work and new ammunition. And if this consortium really operated in this new mode and shake it down, then it could pass that mode on to the Bs and they would be able to work a lot better, and then it could start ingesting a lot of the lessons learned coming down to give more and more power to them. So to try to get that started before people really, you know, if you said, yeah, I wanted to get 30 people together and get them all to really learn how to work in this really new paradigm, how much would it cost some organization to foot the bill for setting up that kind of pilot operation and shaking it all down and learning? Well, why not share the cost? So that's the idea. And then we run into things fairly soon of people saying, what are the deliverables? And he says, well, we'll call this creaky old thing OHS version 1, and we'll be planning the requirements for 2, merging what we're learning about how to live this way on this platform, what you'd like integrating modern stuff, and also what we're learning about the methodologies and conventions that start to work, and we'll come up with a plan for OHS 2. A plan, but we'll also get a lot of experience. We'll also have all these handbooks. But also then if we can get the money, we would then build fast prototype versions of open hyperdoc systems for these people to start pilots of their own. And then assumedly they and vendors would start saying, okay, what do we want to see as products that will support this? And starting to learn about where would you make draw some kind of a line through the system and say below that you really have to have standard. You just have to have an open standard. Above that you can have all the imagination and competitive support you want to. What's that line? how much of the vocabulary goes in there, how much of the conventions, like you can't have buttons appear suddenly that'll do all kinds of weird things if you're going to go read. So someplace in there what your links are, and there's some basic conventions you have to have, like footnote conventions in books and things. So anyway, what is that? And then you can have all kinds of exciting utilities added onto that. Anyway, we've got some flyers. You can come and sit up for 3 days and talk to the other people who come. And one thing is, MCC has gotten very much interested in starting a real nationwide program in enterprise integration, because there's a European counterpart, a consortium that's started out with computer integrated manufacturing and has gone to this whole sort of enterprise-wide thing. So one of the companies, Motorola, that's very interested in our bootstrapping, got them to realize what's here, and MCC likes what we're doing, so they're offering us an umbrella that we can start off as what MCC uses as a precursor to a consortium. They call it a technology study, and so they're letting us use their agreement form, and people then actually can act as they're subscribing to an MCC pre-consortium study, and they pass the money through to us. And then when we form a consortium, they've said you can be free to form your own or be part of theirs. So this has given a big leg up in something like that. So this spring we're going to be trying to actually get it going. It's I tell you, it's hard work to go off someplace and raise a flag to say, well, we're going to bootstrap a consortium, and the world doesn't know what that is, and you have to have your hat out for people to give you money to stay alive while you're trying to get it started. So one thing it takes is a daughter and her husband that will work like hell for 3 years helping make it work. You have a question?
You mentioned very early on in this talk that
hierarchies were sort of easy to implement, and there were other structures, but let's leave those until later. Now you showed us an hour or so of hierarchy. What about other dimensions through which you could look at some of the same data that the hierarchies you happen to have?
Oh, it's you can build links to whatever you want, and there's in our architecture there's a module we call a sequence generator that's actually it can be flipped in and out with replaced just at the call of a user to other sequence generators that can give you any kind of sequence of nodes throughout the whole domain that you want to, based on any algorithm you want to. So we put that in back in the early 70s to give us that flexibility, and we just haven't had exploratory usage people to take it and start applying it, to use it, but it was built for that purpose. And then I'm sure that you can make any structural interconnections you want to all those nodes, the objects that you have in there. So whether you have a sort of one canonical interlinking that's wired in with pointers, and the rest is done with links, so you have two classes of pointers, so to speak, or whether you have more classes of pointers or just one class, or something that you have to start exploring how you're going to put all that to work. But there's something about the hierarchy when you're authoring it, the continuity of your basic flow of your exposition that stands up awfully well. And then with that's as a basic structure, and the kind of links as other options. So those are the only way you're going to learn that is to go after the really heavy work. And when a lot of hypertext systems are used mostly for taking existing bodies of knowledge and integrating them and linking them well in portrayals, and that's a reference access, then you say, well, the next extension is they should be multiple people getting at them, and then you say it's got to be evolvable by the group. And so it's getting to that latter stage that you have to start getting the real using of these things for the system that's going to prevail. Because the reference use only would be kind of dumb if it weren't the same kind as what everyone else is using for the hard work out there. So they have to find pilot applications in different kinds of knowledge domains that go in very intense. And then if you want an open solution, you have to start comparing the requirements of these and generalize on them. So it's
Over 10 years and still pretty much hierarchy is the only abstraction.
But what you have to realize, it's been 25 years, and what you have to realize is that the usage for most all of that was where you're living in a commercial world or something where it's the customer's idea of what he wants to do with it that you have to comply with, and they can bend quite a bit in their world and hardly tax that at all. So there were whole, big organizations doing all sorts of great things with it that used hardly even got the engines revved up. So and it had no money, essentially no money since the mid-70s for anything exploratory. It just makes you cry, sort of.
Several years ago, your colleague David Potter explained to me at the time the system was being used by the Air Force to create training and maintenance manuals. Is that usage still ongoing? And if not, what was their final evaluation of the system?
Well, that system, they got to have a new colonel in charge. It didn't listen the same way as the earlier one. And the lieutenant that was pushing this very, very hard pushed so hard he got a very bad rating and ended up resigning from the Air Force because it ruined his career. Later, a whole communications command had 5 of these mainframes sitting in there supporting a whole bunch of people with a much more extensive than that application. And that got up to the point where they were were writing the RFP to go out on the street for a worldwide, for the whole communication command, that were supporting all the Air Force bases in the world. And so they were writing it around the requirements that they were getting to use Augment and all of this. Very great. And then the owner of the Augment system inside McDonnell Douglas, because it was such an off-brand little thing in a system, who should be up the line in the corporate structure own it? So it was owned by a company that had been acquired just before Timeshare that was in the small business data management business with their own homemade mini computers operating with the PIC operating system and doing that. So we were very much different from them. And so the guy in charge of that, who would have had to budget for the money to port Augment into something modern in order to bid on that, just was way over it, just couldn't see that at all, and the general just said, I can't go ahead. So they stopped it and watered down the requirements, and I think it was $940 million that AT&T won a few months, 8 months later, and I understood that they couldn't meet those watered down requirements even. So there have been disappointments like that, and it's just, again and again, it's the paradigm, the conceptualization of where things are going. And you don't know whether all that batting your head against the bricks is making any progress or not, because when the world finally starts moving, what made it move? You could have sat home and rested instead, maybe. Yes.
About this in relation to Xanadu?
When we're looking for different ways to implement OHS2, Xanadu is one of the things we'd look at, and we'd have to really study it versus this to see how well they tell us it would, and they give us some briefings that are very impressive, and very, very bright guys doing great things under there. But there's the difference about living with a lot of this stuff. Some of the details will get you. So we have to see. Small talk people tell us they can do a fast prototype in 4 months or something like that, just exactly like it. Well, it takes more time to talk between people to figure out whether that's true. But what we really want is a prototype not anchored to be a product and not in competition with the vendors. You know, it's the way user organizations have to have a chance to learn what it is they want and how they're going to employ all this, because there's so much on that human system side of adjustment within an organization that there's just no way that they can buy something that vendors think is great because they built it and then they've got to advertise it. And how much experimenting with the application did they have time to do? Well, today the vendors don't.